Hello, welcome to today's video. I'm going to do a little bit of lecturing first just to get some concepts out there before I head into solving a simple problem that I've solved for myself and for other people and was reintroduced to it just a few days ago helping someone out in the Alteryx world, and that is dealing with non-equivalent joins. Essentially, how product joins are necessary for us to resolve any type of data consolidation that does not include a column equal to another column, which is an equivalent join, and the non-equivalent join is typically what you use for any kind of ranged data. For example, if you are small, medium, or large, you fit within a certain size either by height or weight or something else. If something was short, long, or extended, it has to do with the duration of time that you spent doing it. Then there's a lot of ways that you want to deal with your data and consolidate it within banded ranges so that you can do better reporting. So what is an equivalent join to start with? We're going to just do, like I said, a little bit of lecturing here to show you that we have two tables. We have table A and table B. An equivalent join is where we say one value from table A equals another value from table B. In this case, we say where A equals Z. And you can see that when we do an equijoin, we get one record from this because there is only one record in A that matches that criteria in B, which is blue being a square. Pretty simple. Alteryx handle this through the join operation, and you go on about your processing. But what is a non-equivalent join? Well, what we really want to know is that the different colors are given a parameter, and that parameter determines what shape they happen to be. If they are between 1 and 3, they're a square. If they're between 4 and 6, they are an oval. And so when we do this non-equivalent join, we want to know the shape that red has if it has a value of 2. And so we have to find the range that identifies 2, in which case red becomes a square, blue becomes a square, and green becomes an oval. So this is where you want to match things together. The question is, how do you do that? How does an RDBMS do this as well? But how do you do this in Alteryx? So you start with, what is a product join? A product join is where you match every row in your first table with every row in your second table, and it's called a product join because the resultant number of records or rows is the product of the number of rows in the first times the number of rows in the second. In this case, we have very small tables, so it is 3 times 2. If we happen to have 300 in the first and 200 in the second, then it becomes a much larger number. And I'll let you do that math. And you can see how this grows very rapidly. So you need to be careful with product joins because once you do that, you could get a very large table that takes a while to construct, and then you have to examine it from there. But in this case, when we product join between table A and table B, we get these 6 records, and you can see that we have red with a square and oval, blue with a square and oval, and green with a square and oval. So now once we have all the potential candidates, what we need to do is to resolve according to the ranged or the bands that are in there. And so now what we do is we complete this join by filtering out the records that do not have A, that is between X and Z. So red becomes our square, blue becomes a square, and green becomes an oval. So we build a very large set of data, then we throw out what we don't need, which tends to be most of the table, and now we wind up with what is considered within the range or the banded and the categorization of these records. Now, sometimes when you're joining table, it isn't a straight equijoin nor non-equijoin, but it's a hybrid that involves both of them. In this case, I've thrown in a table C, which again has ranges in it, but there's a range for each color in order to determine its shape. So red, blue, and green each have their own set of ranges or bands. So when I want to process this and get the banded data out, what the first thing I need to do is to create what is considered a one-to-many join. and that is where each record in table A is joined to each of the records that match by color in table B, or in this case, which is C table. And that gives you a number of records that depends upon the matches that go on. What we get out of this then is from my partial product join that red and blue and green all have both of these shapes, but the ranges are different for each of them, so they have their own specific ranges. Now what I want to do is the same as I've done with my equijoin, my non-equijoin in the previous step, which is to match x, a being between the ranges of x and z. And when I do that, I get that red is a square, blue is an oval, and green is a square because they match within their own subset of data. So that is the hybrid solution for dealing with this as well. If you have a very large set of data, odds are the hybrid condition might fit with you. But again, you're doing two joins, one to many, where you're doing it strictly on the matching ID, in this case color, and then the second one, which is where you are doing A is between X and Z, and you're actually just simply throwing out the records that are in there. So let's see how we would do this with Alteryx. So let's go ahead and bring in our Alteryx designer. I'm going to work with two tables. I've been using this one table because it has a large set of data recently, and it happens to be the view that we worked on one of my previous videos, which is the puppy training fact table that has been denormalized. And we'll go ahead and put a select on the end of that. So that's the data that we're starting with. And more specifically, what we want to look at in this, and what we're going to do very quickly, is to limit the amount of data, because we don't need very much of the data for this exercise. So we come into options, we do select, deselect all of them, and simply what we want to do is look at the puppy's name, the trainer's name, the trick name, which is down here, and then the training session time. Because what we want to know from this data set, let's go ahead and move this up so that all the data pretty much fits together. We want to be able to determine which of our work periods this training occurred in. And to do that as well, we'll need to go ahead and bring in our work shifts data as well, and rather than belabor going ahead and finding this table and matching it through, we will go ahead and simply copy it from an old workflow and paste it into my new workflow, and we can look at what we have here being the basic version of the non-equijoin. So what we have here is we have the puppies that were trained by whom for what trick and at what time, but we want to know which of the shifts that occurred in, and we have three shifts, a morning, afternoon, and night shift from 8 to 11, 12 to 8 to 11:59, because we want to ban that. It's 1 minute before noon. We have 12 to 13:59, which is 1 minute before 4, and then we have the 4 o'clock to the 8 o'clock at night, which is when we go ahead and we close the Puppy Hill factory. Now keep in mind that when you build these ranges, you need to know whether or not the both ends are inclusive or exclusive. In other words, is there any overlapping? A lot of times you'll have the start time and the end time being strictly hours in this case, and you got to make sure that your banding criteria matches. I tend to like to be a bit more pure, so if we have 8, 12, and 16 for the beginning of shifts, we take 1 minute off of those, and that actually becomes the time that we want to deal with. That being said, what do we need to do? Well, we need to do our product join. And the question becomes, how do you do a product join? Well, it's sort of hidden here over in this Append Fields. We drop this down here, we link up the target and the source. you'll notice that there's a little warning down here because this is indeed the product join. It's called the Append Fields. Took me a bit of time to find it, but once I found it, it solved a lot of issues for me as I went through it. And you sort of know it's a product join because it's warning you that if you have a lot of records that you're product joining in there, you're going to get a very large data set. And so it wants to give you an error if there's more than 16 records being joined into as a product. So you need to be careful of that if you have a lot of records that you're putting together in your product join. Go ahead and you can turn this into, and we can do this typically, which is allow all appends just so that we know what's going on. Always a good idea if you're not sure, go ahead and choose the error option, just because if there's a lot of data, it will go ahead and stop it. Once we've done that, we can run this very quickly. We can see that our 6,100 records have been combined with our 3 records, and then we end up with 18,300 records. Again, we only want one of each, so we'll need to filter this out. Again, just to be a bit simple about this, what we want to do is there is not a between operator within the filter. One thing I like to have, so you need to build that between filter yourself, and that is where our session time is greater than or equal to the start time, and the training session time is less than or equal to the end time. That puts it in that band. It's a bit complex to create that, but a between would work. But this also gives you ability that if you do not have mutually exclusive start and end times, then you can always just make this a less than the end time as opposed to less than or equal to it. It's your option for how you're doing that, how you want to build that filtering criteria. And you can see now that once we've done that, we have our 6,100 records that have been filtered out that match within their specific bands. To finish this up, all that we need to do is just go ahead and drop a select on this. Drop it onto the true side because those are the ones that we want. And once we look at the data, we no longer need the start and end time. We just simply need the shift name. One thing that's been brought up and was working with someone else with this data set is that what happens if that data is out of range? I don't want to lose that data. I just want to identify it as out of range. And so then we need to fall into our SQL minus process where we want to find out any records that are not in this outgoing data set. So we will simply do that through a join. If you've seen my videos on the set operations of intersect, union, union all, and minus, this is what we're doing here. So we simply bring our records into the left side, and we're going to drop these down because we're going to put a comment in here. So what we want to do is make sure that we join on all the applicable fields. We want to join on puppy name. We want to join on trainer name. We want to join on trick name. And then finally, we want to join on the training session time because that is what makes this unique. And when we execute that, all that we'll need to do as we skip ahead in building this is that we'll go back into our join operation. We'll go ahead and union these in. And again, the left side of this, and we'll put a comment in there just so we remember about it, is that the left are the unmatched records. And essentially, with the reminder, this is the minus set operation. Even though there are none in here, it's always nice for this workflow to go ahead and handle them anyway. And then we'll drop a browse on the end of this. And obviously what happens here is that there are no records on the left, so our 6,100 records come straight through, with each one being in a specific shift. We can look through our browse. You click on shift and you can see that we have a nice distribution of values. that each of the morning, noon, and night have been allocated across the data. If things are a bit more complicated, for example, if we want to find out when the trainers were working outside of their scheduled work hours, it's always a good one to do, that we'll want to do basically the same type of work. Let's go ahead and pull this in to a new workflow. So this is our partial non-equijoin. And what we want to do in this one is I have another table that has the work hours for each of our trainers. So this is their work schedule. We run this through just so we can take a look at the data coming out of the denormalization. We have our 6100 records. And now what we have are a few more records because each trainer has their own start and end time. So each trainer, and if you notice that while most of these have one, Sue actually works 2 different times. She works from 8 to noon and from 3 to 5. So that gives us our one-to-many relationship during at least here, but again, it matches the trainers up specifically with their work schedule, not any general work schedule. And then when we resolve this, we're going to do this slightly differently. Because the first thing we need to do is our one-to-many, which is our equijoin. And so we simply bring this equijoin in here. And on the left, we have the trainer name, which is on the right. So now when we run this, you'll see that through the join, we've gone a little bit larger than the 6100 records because we did have some specific shifts. But here you can see we have the puppy names and the trainers with the trainer and their shifts. So each record was spread out into give it the working schedule for the trainers. So now we want to go ahead and drop another filter onto this. I was going to show you another way of doing this same filter. There happens to be, while there's not a between, there is a function. If you looked at my functions video, it is the bound function. And what I can see is that this sort of gives me the ability of doing the range, and whereby what bound returns is it returns the value of the first parameter if it is between the start time and the end time. If it's not between start time and end time, it gives you if it's below the start time, it gives you the start time. If it's above the end time, it gives you the end time. So it's looking to see if it's in the bound. Otherwise, it tells you whether it's lower than the bound, at the lower end of the bound, or at the upper end of the bound. What that lets us do is make our Boolean calculation saying that if the bound function returns the training session time, then it was within range. Otherwise, it was out of range. Not quite the between, but it sort of gets the job done. We can again look at what's going on here, and we run through this. You notice that we've got less than the 6100 records. We've got a lot of our trainers working out of schedule just to deal with our puppies. We want to find who they are, and again, not to belabor this point, what we're going. So let's find those missing records by doing our minus. We'll do that in a couple of steps. First step, let's go ahead and clean up our data coming out of our filter. Again, we do not need the right trainer name or start date or start time. We just need those top 4 columns. And then what we're going to drop in is our join. We want to match everything up that we have: puppy name, trainer name, trick name, and training session time. Run this very quickly. You'll see that we have our 4422 here, and again, the left is the missing data. We have our 1678 records that were out of work time for our trainers. Kudos for them to doing that work out there. And then finally, all that we need to do is to bring in our union, bring in the in-session records, bring in the out-of-session records, and we want to do one last thing, which is to deal with those nulls. So we'll drop in a formula. Formula is very simple, that if the start time is null, we give it a 0 as a Boolean, otherwise we give it a 1. So if they are during the work indicator, it will be true or 1. If it is they're not during their work time, it will be a 0 or false. Drop a browse on the end of this. Go ahead and run it. Where did our start time go? Ah, we need to leave start time on here. Love doing things live. So let's go ahead and clean up when we're done here. Dropping a select in. Sorry, I had a momentary mind blank. We don't need start time. Just simply need our during work indicator. So now when we run it, we can see that there's a bunch of trues. There are some falses down there as well. Looking at this, we see the split of the 6,100 records. So everybody's accounted for. 72% were during their work shifts and 27% were after their work shifts or before their work shifts. Were not really true, but we could also try to figure that out if we needed to as well. But in this case, we've now done 2 non-equijoins, one which was fully an equijoin, that we wanted to go ahead and anoint our records with the shift from the overall company standpoint. And then the second one is that we wanted to identify which of our trainers were training within shift and which ones were training without shift within their own work schedule. So it was the hybrid, or first with an equijoin to do an actual one-to-many, which is close to a product join, and then filtering out the results and getting our work done that way. I hope if you're working with non-equijoins, wondered how to do it, this helps you solve those problems. Don't forget to subscribe, drop some like comments in there as well. If you have any issues, you have any questions, please drop a comment with that in there and I will answer it as soon as I can. Thanks for watching.